A thin envelope of gases called the atmosphere surrounds our planet. Not only is this tenuous gas vital to our very existence, but also fragile enough to be ruined by us. Air pollution, a man-made destructive wonder, has over the last century or so grown to alarming proportions. And our understanding of the consequences were a bit slow to start. But what little we know of how pollution affects our atmosphere has been sufficient to put the scare in us. But human beings that we are, we cannot agree on the action to be taken or hold back our greed. We somehow take nature for granted. Over a period of 24 hours, you breathe in some 15,000 liters of air. It has been estimated that a person can live for 5 weeks without food, for 5 days without water, but for only 5 minutes without air. And we are out to ensure that we do not have enough clean air to breathe. In this second program on Early Action Counts, we will discuss the level of damage we have caused to the atmosphere, how we assess it, and what we can do about it. People around here have to inhale all this exhaust soot. They may be used to it, but the situation has continued to be hazardous over the last 25 years or so, and perhaps will deteriorate further.
In most of our cities today, you have large number of vehicles and they're extremely polluting, they're very dirty, and they contribute in a very large measure to air pollution. In a city like Delhi, for instance, there are estimates that 70% of the air pollution in our cities, this is outdoor air pollution, comes from vehicles. And this is the case across the country. The Pollution Control Board, the Central Pollution Control Board, CPCB, monitors a large number of cities and their air pollution, and it finds that almost 17 cities pollution levels have reached critical levels. Critical means at least 1.5 times above the standard.
How serious is the problem of air pollution in the capital city of Delhi? Here, the air is not only hazy and murky, but also uncontrollable. Can we wish away traffic and emissions coming out of these ever-increasing number of motorized vehicles? Or should we shift to bicycles? Clearly, to answer such questions, we must measure something. But what? Oxides of sulfur? Or oxides of nitrogen? Or carbon monoxide? Or suspended particulate matter? All of them. The investigators for this project are students from a neighborhood.
This is our Sampling Pro, from where we take the samples from the environment and sucks through this pump.
But sir, the air outside, it will contain some moisture, so doesn't it dilute the amount of pollutants in the atmosphere?
We are not allowed this moisture to enter this analyzer. We have a moisture trap.
The particles, suspended particles?
No, only gas particles is entered.
So you know that we are sucking the ambient air, and these are the analyzers, and these are analyzing all the gas that we are sucking it. The sample is coming into the van, and it is distributed to all the analyzers, which are monitoring nitrogen dioxide, sulfur dioxide, carbon monoxide, and ozone. So if you see on the monitor now, this value is well within the limit, and this NOx is the main pollutant from diesel-driven vehicles. you see ozone is 0.013 ppm at present, and this ozone is the ground level ozone, not the top level ozone, which is beneficial to us because it absorbs ultraviolet light. Then you have CO, and the main source of CO is the vehicle, petrol-driven vehicle that move outside. Then you have SO2 concentration, which is 0.002 ppm. Petrol-driven vehicle are main source of this, as well as the industrial emission which use coal or any fuel. This data from the analyzer is directly coming on this computer. Simultaneously, this data is going to the central computer in the CPCB, Central Pollution Control Board office. So now, after taking the van back, we analyze the data and keep a track of what is the movement of the pollutant in this area.
The concentration of air pollutants are either expressed in microgram per cubic meter or more frequently as parts per million, in short, ppm. ppm by volume means the number of molecules of a given pollutant per 1 million molecules of air. The investigations of ambient air quality monitoring stations in the National Capital Region of Delhi, conducted by the National Environmental Engineering Research Institute at Nagpur, show this. The higher the bars, the greater the concentration of major pollutants. Pollution incidents can sometimes become tragic. In 1952, during the winter days of December, the city of London remained covered with one of the worst green-yellow fogs for almost 5 days. The fog was so intense that people in cinemas could not even see the screen. Had not 4,000 or so people died during these 5 days, and the week following, twice the normal, few would have bothered about acute pollution disasters. The word smog is now commonly applied for such forms of air pollution. The combination of smoke containing soot and fog made from condensed water vapor suspended in the air near the surface of the earth produces smog. This is a different form of smog that spreads into the suburbs. The nitrogen oxides contained in the exhaust combine with unburned hydrocarbons trapped in the humid air. When this combination of suspended chemical pollutants is exposed to intensely bright sunlight of short wavelength, photochemical smog or haze is born. And this smog produces a range of secondary pollutants, including powerful oxidants such as peroxyacetyl or peroxybenzyl nitrate, more commonly known as PAN or PBN respectively, and ozone. Not only is PAN primarily responsible for the eye irritation, which is so characteristic of this type of photochemical smog, but it affects vegetation also. We can escape outdoor air pollution, but plants may be exposed over long periods. This is a poplar tree. It grows very fast and its leaves fall in autumn. But when photochemical smog blows in like this, the poplar leaves eventually come to look like this. as if they have been burned. Scientists here study the effects of photochemical smog on plants and trees. All these airborne pollutants may become dangerous when these concentrate and build up over a certain area during a weather condition called thermal inversion. Such a situation occurs when a layer of warm air settles over a layer of cooler air that lies near the ground and acts as a lid. This prevents pollutants from rising and scattering. The longer the inversion lasts, the greater is the buildup. And these remain trapped in until rain or wind breaks up the layer of stationary warm air, allowing the impurities to rise up. One such thermal inversion, which had disastrous consequences, occurred in December 1984. An accident at the Union Carbide factory at Bhopal led to the release of methyl isocyanate, a poisonous gas. The situation was aggravated due to thermal inversion, not allowing the poisonous gas from dispersing. The accident killed about 2,500 people overnight and injured more than 200,000. Many of them are still suffering from the after effects. A small fraction of the particulate matter may be metallic particles such as lead, chromium, beryllium, nickel, arsenic, and vanadium. Heavy metals such as cadmium, zinc, and mercury are released into the atmosphere from metal smelters and refineries, fertilizer, pesticides, and cosmetic manufacturing factories. Despite their low concentrations in the atmosphere, some of these are extremely harmful and lethal to living organisms in the long run, as more and more of these accumulate and poison the air. Cadmium neither gets burnt by fire nor cleared by air, and its accumulation can spoil the kidney. Lead products such as tetramethyl lead or tetraethyl lead are added to petrol to improve the anti-knock quality of the fuel. Pigeons living here have been found to contain about 10 times as much lead as their more fortunate rural brethren. Near toxic levels of lead are suspected to be accumulating in the bodies of children who live in this busy urban area. By binding to the enzymes, lead poisoning can damage almost any vital organ of the human body. Perhaps the most controversial environmental issue is acid rain. Even without air pollution, all rain is naturally slightly acidic because it contains carbonic acid formed by the reaction of water with the carbon dioxide in the atmosphere. But all the additional carbon monoxide and carbon dioxide we contribute through burning of fuels, what about them? This rain is more deadly and damaging. It kills numerous organisms ranging from fish to forest. What causes the acid rain? The cause is complex and differs from place to place. Acid rain is rain with a pH of less than 5.6. Common acid-forming compounds includes oxides of sulfur and nitrogen, halogen compounds, and a variety of hydrocarbons. Through complex chemical reactions with moisture, they can become highly acidic substances such as sulfuric acid, nitric acid, and hydrochloric acid. Vast stretches, millions of acres of forest, including wildlife, are vulnerable to damage by acid rain. The acids burn the leaves and leach nutrients directly from the plants. There is stunted growth of crops due to affected soil and water. In many parts of the world, thousands of lakes are dying biologically as a result of acid precipitation. As the pH falls below 4.5, all fishes die, leaving only a small number of acid-tolerant ones. And as clouds move from place to place, even across countries, the source of pollution could be someplace and the acid rain could affect someone else. A real global problem. And this acid deposition from the Mathura refineries is perhaps the cause of damage to the Taj Mahal. These are pieces of marble similar to the marble of Taj Mahal. We put them into different solutions of sulfuric acid and nitric acid of different concentrations. See what happens. Carbon dioxide gas is coming out and the color of marble is changing, becoming pale. But in reality, this process is very slow. One method of combating the harmful effects of acid rain is spraying alkaline substances such as coal ash to neutralize the acid on land and water both. However, the neutralization is only temporary and may have harmful side effects. Metals, concrete, and even nylon stockings deteriorate faster because of the primary as well as secondary pollutants. Steel surfaces, for example, may wear away as much as 30 times faster in cities with polluted air than in a rural area where there is little air pollution. Air pollution is a continuing threat to our health and welfare. We can clean up land before we use it and purify water before we drink it. But except probably in air-conditioned rooms, we must breathe air as it comes to us.
The major problem with indoor air pollution is chula smoke. In most parts of India, as you know, rural households cook even today on chulas, and they use biomass, whether it is wood or agricultural crop residues or cow dung, to be able to cook their food. And the ventilation of our houses in many parts of the country is such that the smoke is trapped within the houses. And researchers have now found that it is equivalent, the women who are exposed to the smoke from chulas, it is almost equivalent like smoking 20 packs of cigarette a day. the amount of toxins that get into the body.
Is there any correlation between cases of persons breathing polluted air in cities and deaths from lung cancer? We may not have a definite answer, but a number of research studies reveal a strong association between lung diseases, including lung cancer, and significantly high ambient levels of polynuclear aromatic hydrocarbons, PAHs, benzene soluble organic matters, BSOM, and lead metal. All these are carcinogenic. Unfortunately, air pollution levels, both outdoors and indoors, are crossing danger levels globally, particularly in large metros. It's time nations galvanize into doing something about reckless emissions and cleaning up the fouled air. What are we doing about it in India? In order to prevent and control air pollution, the Air Act was passed in 1981. An act is not enough. Action is the need. Covering some 90 cities spread all over India, 300 or so air monitoring stations collect the air samples and determine the levels of air pollutant ingredients. Since India is among the toppers in emission of air pollutants, some simple and drastic control measures are imperative. The focus is on drastically reducing the generation of greenhouse gases. Number of automobile vehicles will continue to increase and factories cannot be shut down. Among the steps that can be taken are regular monitoring of emission levels of pollutant gases, making the use of catalytic converters compulsory for all petrol-driven vehicles, particle traps in dieselized vehicles, and, where possible, shifting of factories away from human habitations. Ensuring proper insulation in factory boilers and cutting down electricity transmission losses can also bring down the levels of emission by as much as 20%. What else can be done to reduce automobile pollution? Should not the vehicles with old technology be banned from big cities? As the economy grows, and with it its energy consumption, we may be forced into making some fundamental shifts from coal-fired thermal stations to gas-fired ones where low sulfur fuels cause less air pollution, CNG, compressed natural gas compatible vehicles such as cars or buses, because it is inexpensive and non-polluting. This is being tried out in Delhi. Other cities may follow suit. Of course, some of these steps will add to the cost, but surely they cannot be costlier than our health. Getting back a whiff of fresh air will take time. It will take determined and sustained efforts to undo years of neglect. The atmosphere, although it affects everyone, belongs to nobody. No one has sole responsibility for it. This makes it more difficult to protect and easier to pollute. It also means that even those who do not pollute it suffer from the pollution of others. And certainly, dilution is not the solution of pollution. Getting the act together and concerted effort is the only way forward. It is encouraging to note a heightened awareness worldwide, and people and institutions are coming out and joining hands to do their bit for the environment. What about you?